so-called Farmer-French three-factor model. After having established in their 1991 paper that there is something fishy going on in terms of size and value premiums. These premiums are well above what is justified by beta differentials alone. So they said there must be other sources of systematic risk other than the market risk. Example, when there's a recession, uh, let's say there's going to be a deep recession if this Trump tariff nonsense continues. Is there any chance at all that Apple is going to be financially troubled? They'll make less money, sure, but you wouldn't have any fear that Apple is going to go bankrupt. But on the other hand, smaller companies and with recessions, typically there is something called credit crunch. Banks actually differentiate, everything else being the same, between large companies and small companies. They are a lot less likely, given the same credit ratings, uh, they are a lot less likely to lend to smaller companies compared to bigger companies. So there is size actually is an indicator of potential financial fragility. Similarly, book to market, typically growth companies such as Google, Nvidia, Apple, Amazon, and stuff, they have high growth expectations compared to value companies. They don't have high growth expectations. So they said these may be indicators of different systematic risk factors. We don't know what they are, but if we can come up with portfolios that mimic those factors, then we can estimate a model. The way you do a multi-factor model is expected return on the portfolio. We're going to do some alpha plus beta times plus gamma 1 times factor 1 if your model is proper, if the multi-factor model is proper, the plus the risk-free rate, of course, the alpha of the model should be 0. I mean, I'll give you an example quickly. I'm going to do it for the entire data. So let's calculate premium for decile 1. Basically, decile 1 return minus risk-free rate. Come on. Oh, I also need the markets return. This is the so-called market risk premium. Market return minus risk-free rate. All right. Cut. I'm going to do regression, and under data tab, if you also clicked on data analysis thing when you put in the solver, you'll have it there. Data analysis, and find regression. What is your Y, your dependent variable? That's my premium for the small stocks. What are my X's? In this case, I have two of them, risk-free rate and market risk premium. Oops, Control C. If you click on labels, that says the first row has the labels. I'm just gonna hit OK. Okay, apparently I did something wrong. All right. Now the estimate of the intercept, the estimate of the alpha, that's the oh, I'm sorry. The estimate of the alpha, that's the risk-free rate. Oh, no, I shouldn't have risk-free rate. I made a mistake because I already calculated the risk premium. I should have only the market risk premium. The coefficient on intercept is the estimate of alpha, and that's the estimate of beta. Okay. Again, you should never estimate betas using 100 years of data, because why? Over time they change. If for no reason, companies change their size. Typically, we use 5 years worth of data to estimate them. Just taking this at face value, that alpha is 0.1%, but that's per month. That's about 1%. So in a sense, this alone says, I mean, it's not statistically significant, but again, since I'm using 100 years of data, I'm not worried about that. But it's an economically significant number. This basically says there is about, let's multiply that by 12. There's about 1.3% return on smaller stocks that is not justified by beta alone. I mean, if I did the same thing using decile 10, I'm going to redo this for just for the hell of it. Data. It doesn't change the previous regressions. As you can see, the betas of the large cap stocks are lower, 0.93. Small cap was about 1.4. So that alone explains a lot of the size differentials. But this says there's an unexplained, it's not too big, only 0.1% per year. So it's doing well for large cap stocks, but it's not doing well for small cap stocks. When we do some practice, we go with rolling 5-year windows and estimate those. Let's stop here today. There's a little bit more on the chapter about arbitrage pricing theory. Read that part yourself, but I'm going to do some sample problems and post the videos for those later today, including quizzes. And we'll do Jeopardy on this on Thursday. All right. Chapter 8 is going to be a lot more fun with looking at all those abnormal stuff going on.